6.1 to 6.9 is done. Revision. 6.10 now. Presenting data from springs. Okay, so this exercise, we are going to hang some material, some heavy objects on the spring, and then we will solve some numerical, or we will see what happens when we hang something from a spring. Okay, and in real life, you must have you must have seen springs in so many places, like in trampolines.
Uh,
Okay.
but also, Mr. How do I have like you know, in cars there are springs, but they make oil springs. How do they work? Like, how does the oil does not make it go to the elastic limit?
Oil in springs. I
Or
didn't get
like,
it.
you know, oil springs in the cars. You know, like the
The
in
shock
the there are in
absorbers.
trucks.
The shock absorbers.
Yeah, yes, like inside the above the tires, there is a spring
Yes.
connecting it.
Yes. So that is for the shock absorbing. When you have shocks or jerks on the way, your vehicle will
Mm-hmm.
protect your vehicle. Your vehicle, your spring, I mean the spring, the shocker will protect your vehicle from being damaged.
Damage.
Yani they will go inside, they will shrink in size to in
Okay.
order to compensate for the jerk or force. If the spring is not there, the car or the vehicle will face a big force resistance, which can break the parts, which can make the parts loose. So that's why spring is very, very important, especially in heavy vehicles and
Like
cars
truck.
and trucks. Yes. Okay. So the elastic limit, we have already discussed elastic limit, that elastic limit is that limit until which the object will come to its original length. Yes. But if you take something more than the elastic limit, what will happen? Hmm?
If it goes beyond the elastic limit, it won't return back to its original shape.
Yes. And it will
Break.
enter, it
Like
will enter the plastic
enter.
region. It will enter the plastic region means when you
Yes.
elongate it, when you extend it, it will stay
It won't.
elongated. It will stay, yes, it will stay long. It will not come back to the original small length. Okay, that's the process. Okay, now Suma is on the trampoline. The label says that the weight limit for trampoline is 1200 Newton. The spring must be below their elastic limit when the weight is. Yes. So for example, on a trampoline, if you read the instructions, they tell you that the maximum is 1200 Newton, or roughly like 120 kg. Okay. So it means the kids that are playing, you have to adjust in such a way that their weight does not increase, exceed by 120. For example, if average 40 kg guys are there, how many guys do you recommend at maximum? If a boy weighs 40 kg, okay, then how many boys like that can play on the trampoline at the same time? If the limit is 120 kg,
Three.
three,
30, 30. Wait, 30, 3.
30 kids.
No, no, 3, 3, 3.
You always think
Baba,
about destruction,
Three.
mass destruction. Three, okay, 40, 40 and 40, 120. But if you have like adult people like 80 kgs or 70 kgs,
Two.
then you cannot put two. Like if you will put 70 and 70, it will be 140. It can break, it might
One.
break. Okay, so just one only. And with him, he can take one boy if he wants to destroy that boy, 40 kg boy. Okay, that's good. If you want to hit that guy. But so you got my point that you have to maintain the weight. Yani your weight should not exceed 120 kg. Why? Now, what is the reason? The
Measure.
reason is every spring has some elastic limit. So if you put a weight of 120 kg or less, and then you go out of the trampoline, what will happen? The springs will come back to their original shape because they are in the elastic limit. But if you bring a heavy boy or two boys or two big adult, like two men, what will happen? With passage of time, it can break also, or the springs will become big in size, elongated, and they are not returning to their original shape. Yani the trampoline will not be that bouncy. It will just hang like originally the trampoline is something like this. Very stretched out. Yes, it's like this, stretched out. But when heavy people are resting on it, what will happen? It will become like this, saggy. The trampoline will become saggy. Yani, what am I drawing? Yes, something like this, saggy.
Hello, Mister.
Hello, assalamu alaikum.
Alaikum assalam.
Okay, so I was telling about elastic limit of springs. Okay. Now recording results. And we studied Hooke's law. Who can describe what Hooke's law states? What does it say?
I know.
Yes, tell me.
The extension is the proportional to the amount of force applied.
Yes. The extension is proportional to the amount of force applied. Means what? If you apply more force, there will be more extension. If you apply less force, there will be less extension. And it varies in a linear manner. For example, you apply 10 Newton force. Okay, you see 1 centimeter extension. So if you apply 30 Newton force, how much will be the extension in the body?
2.5. 3.
Not 2.5, 3. Okay, 3 times. So this is how Hooke's law works. Okay, so this girl did some activity. Okay, and she is hanging some weights on the spring. She hung 1 Newton load, and what did she saw? She saw 1.1 extension, yani extended.
Yes.
This is the original length. In this, there is no external weight. Yes. So how much is the extension? Nothing. It's in the original, yani resting position. So extension is what?
0.
0. Extension is not the original length. Okay. Extension means what? From the original length, how much did it come out? Yani it was something like this before, but now it is like this. So how much is the extra from here to here? This is the extension. Clear? So she did some experiment, 2, 3, 4, 5, 6, 7, 8. And when she hung 8 Newton, she observed an extension of what? 11 centimeter in the spring. Now taking these values, she created a graph, a line graph at the next page. Look this. Okay. For example, I will take a screenshot and paste it on the top. Now look. The first point, 1.1.
Yes. Second point, 2.
2.2. So 2 and 2
No,
here.
2.0, Mister. Not 2.2.
2.0, yes.
Yes.
The third point, 2.5 centimeters. So third point, 2.5 centimeter here. Fourth, 4.2, like this. After she plotted the points, these were the points with that she plotted on the graph.
Yes.
Okay. And she is seeing that after joining them, she is seeing that one point is not lying on this line. One point is slightly away.
Yes.
Yes, now we will see why is it away. Yes, in scatter diagram. You remember I told you scatter diagram long time back? I don't know if I told you guys or not. Strong positive,
Yes.
strong negative,
Yes.
weak negative, weak positive. Yes. Did I explain?
No.
Like
I don't
there
know.
was four squares in the graph. The one on the left is negative, and no, I don't remember.
No.
Strong negative, strong positive correlation, weak positive, weak negative. No.
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 Maybe it's for grade 8. Maybe.
It's grade 60.
So when you have, for example, when you have a graph and you plot some points, but sometimes they are not coming in a straight line, what you do? In order to make a straight line, you cannot pass it through all the points. So you have to make a line that is passing approximately from the center, something like this.
Yes.
Okay, like this. In which
But
way?
Mr. Also
Maximum lines are passing through the line, and maybe one point is here and there, and this point and this point are here and there.
But Mr. Also, the line has to be from 0, not flying.
No, 0 if the values are starting from 0. If the values are not starting from 0, it
Yes.
will be just flying. Okay, it will be here also.
Yes.
Until I mean straight line, something like this. Yes. Okay. So this line that passes through most of the points, this line is known as line of best fit. Okay, because it is very fit. It has 6 packs. Okay. So this line is known as what? Line of best fit.
It hits the gym, Mr. with its hand. It hits the gym.
It doesn't miss the leg day also. Okay. So points that don't fit.
Anomalous.
Anomalous. Anomalous. Anomalous.
Yes.
Okay. So points that don't fit. Like as we observe that this point is like not matching with the other results. So one point was far away from the line. This is called an anomalous result or ajib result. Okay. Or strange. So Sumo probably measured the extension wrongly. Maybe this calculation she did wrongly. So maybe she need to recheck her calculations. At what
Yes.
point it happened? It happened at
2.5.
2.5, this one. When the weight was 3 Newton.
Yeah.
Okay, here. So when the weight was 3 Newton,
The
she
extension was
got
2.5.
this answer 2.5. So she needs to recheck whether she's still getting 2.5 or not.
Yes. You know, Mr. Soma is a Syrian football player.
Oh,
Yes. He plays in Qatar.
okay. So what should we do with these strange answers? They should be identified first and then should be repeated
Check.
or checked. Why the mistake happened? Maybe because of our human error, or maybe because of the machine error or something, or maybe the 3 Newton was not actually 3 Newton. Maybe it was more, yani maybe the problem in the weight that you are hanging. Okay, so you have to figure out.
Or you
Why
didn't do
the-
it at the perfect spot, or not a good enough spot.
No, she's hanging the weights. Maybe the 3 Newton weight is not 3. Yani maybe it has a manufacturing defect. It's 2.8 something. So we need to bring a weight that is exactly 3 Newton. I'm telling you the possibilities. It's possible that the weight is okay. But my calculation was slightly off. Yani the ruler is here. Look, this is the ruler. And after hanging the weight, this is the total length. So maybe here I made a mistake. Yes, it's possible.
Yes.
Yes,
It
we are
looks like an
inside. We
iris.
make mistake.
Yes, we are in some mistake. So as are the results reliable? So we have to think with ourselves. Are the results reliable? Reliable means what? Are they giving suitable answers? Are they giving factual answers, correct answer, or are they giving totally irrelevant answers, like wrong answers? Okay. So for that, she did what? She repeated the experiment 3 times. Yani she repeated each measurement 3 times. Yani she hang 1 Newton, she takes the distance. Then she takes 2 distance. Then after completing the experiment, she's again doing 1 Newton, this centimeter, 1 Newton, this 2 Newton, this centimeter, 3 Newton, this centimeter extension. Then she did it one more time. Okay. 1 Newton, this meter, 2 Newton, this meter. Then 1 Newton has how many values? 1 here, 1 here, 1 here. What is she going to do?
She will check the most accurate one of them, and she will choose it.
How do you know that which one is accurate? The machine will speak for itself or what?
No.
You are the one conducting the experiment. How do you know which one is accurate? You take the average of these 3. You
yes.
take the mean of these 3. Okay. Same for 2 Newton. 2 Newton, for example, it's giving me 2.5 here. It's giving me 2.8 here. It's giving me 2.7 here. What will you do? You add them all and divide by
3
to get the average. That's why it is written here. She repeated each measurement 3 times. Repeated measurements make the data more accurate and reliable. Okay, this chapter was not difficult. This is very simple.
Yes.
And we studied basically about Hooke's law. Simple. We studied about Hooke's law, the activity based on Hooke's law. Now levers we have already taken. I will just tell you what we discussed. We discussed FLE. That if fulcrum is in the center, it's a first class lever, load, second class lever, and effort, third class lever. And what is real life example of first class lever? For example, if you have scissors.
Yeah, scissors.
What category of
it will
lever
be
it is?
first class. Because the pivot is in the middle.
Yes, Ahmad Fuad.
I'm here, mister. I know, I'm here, mister. It is the first lever if the fulcrum is in the middle. The second, the scissors is. Wait.
Example
the
of which
second
class
is
of lever?
the scissors. The scissors is first type.
Okay, how is it first type? Tell me, where is fulcrum,
Because
where is
the
load,
pivot-
where is effort?
Okay. Wait, mister. The pivot is at the middle. The load is at the end.
And what end? Left or right?
Left end.
Yes, and effort
And
you
the
apply
effort is at
here
the
near
end.
the handle. You put your fingers inside. So fulcrum is
Yes.
coming in the middle. It means it is a
First
first
type.
class lever. What about stapler? What class of lever is that? A stapler.
Oh, wait,
Ibrahim is among us.
Yes.
Since how many months he's with us?
No, like
actually, just like I only missed 20 minutes, and this lesson is easy, and we already did it, so I didn't really miss much.
20 minutes.
You sound like you live in a cave.
Yeah,
Underwater submarine.
You still need
Military.
the
He's a
information on how
military guy.
to make lever.
He's a military.
Oh, Mr.
So-
Now work.
Okay,
now, for
so
example, this is fulcrum here, and
yes,
we apply the effort.
Effort
something
in the
like
middle.
here. Or here
Yeah,
also sometimes.
Yes.
yeah, but the load
Yes,
is down.
but I put the pressure here in this region. I put the pressure here.
Yeah.
So
Why,
effort.
mister?
And you put the
And
paper
the-
where? Here.
No,
Down.
No,
not here.
down.
Or
Not
you
here,
put
mister.
the,
You
or, you,
don't.
or you put your hand here.
No,
Yes,
no, Mr. Down.
my hand very big.
Down. We put the paper.
You know, Mister, this first class, second class, and third class levers is not in the book, but I told the Mister in our class about it. Then he brought it in worksheet.
I have
He
now
bring in
wings,
worksheet?
mister.
First class
Yes.
lever,
Look
second
like
class
wings.
lever?
Yeah, it's now in the worksheet.
Wow, say thanks to me. I'm increasing your job.
Mister. Now you mister, the hand looks like wings.
Chicken wings.
No, not chicken wings, just wing. Normal wings.
Uh,
The wheelbarrow, Mister, is a third class, right?
wait, I'm looking something else. Okay. Let's go with this one. Our load is here. Load is where? Here we put the papers.
Yes.
Yes.
Here we put the papers. So here is our load. But yani if I zoom in, ooh, high quality. Yani this is your load, but this is your effort.
Yes.
Yani as far away you put your effort, the easier for you. And because the handles are long, you create a big momentum. Okay, so the far you apply the pressure, the easier for you to press it. Okay, so the effort will be where? This is the effort. This is the
effort will
load.
be the up.
So load,
Up.
no, up and down both. I mean, I'm not saying just one place. You put the effort in both places by your thumb and your finger. Okay.
No,
But
no,
load
no,
will
mister.
be
How
in the-
you?
Should
How,
I give
mister?
you? Should I give you private sessions for how to use a stapler in 2023? I hope
Yes.
you can imagine this simple. So stapler will
No,
be which
mister.
class lever?
You cannot have two efforts. Only one.
How I cannot have two efforts? I can have. From the top, I am applying pressure on thumb, and at the bottom, I have some other fingers.
I play only on top.
No, Mister,
So the
wheelbarrow
load
is
is
the
here.
third class, right?
So it is the
Yes.
second class lever. Okay, so this is first.
Second.
This is second. Wheelbarrow.
Third class.
Load is in the middle.
Yeah.
So second class.
Yes.
Oh,
But I think the stapler can be third
What
class
about
because of the effort.
the dry fruits cutter or nut cracker?
Nutcracker
third-
is
third class.
it's the wait wait the nut. Can you bring a picture, mister? I'm stupid. Very
Yes.
late. Can you bring picture? Oh yes, this Habibi.
Uh, the effort, Mister, is at the beginning, right?
Now wait,
The
effort and
fulcrum
the
stands somewhere here.
Yes.
yes, it is in the one little pointy spot.
It's not working. I will write
The
it
load
here.
is in the
Yes.
middle and the effort.
Fulcrum is here. And where do you put these walnuts? You put it here.
Yes.
So
Yes,
load is here.
load. Okay,
And,
and then the
is
effort.
Your effort goes here.
Yeah, so it's
Oh,
second
so it
class.
is second class. Sorry. This is
This
second
is
class.
second.
Mister, if you will put FLE together, it will be forward, left, east. Forward, left, or left, forward.
No, Faiz.
FLE.
No. Faiz like. No. FLE. Faiz likes.
Egypt.
Faiz likes.
Faiz likes Egyptian. For example, you have this favorite toy.
For salad.
Yes, I remember chicken wings. We hold it with this خلاص.
مستر كان يا
ترابيزة.
Yes, Adnan, go for it. Which class lever is it?
Which
Adnan,
class?
I think became hungry after seeing this image. Tell me which
Mr.
class
Are you
lever it
going-
is.
I will tell
1,
you
2, 3.
what's- Yeah.
What
One,
will
two,
come at
three.
1? What will come at 2? What will come at 3?
One is fulcrum.
Yes, 1, there is fulcrum here.
Two is effort.
2, you put your effort here. Yes, correct. You put your
Three
effort
is
here
load.
and here. And 3 is the load, correct. So this is which class lever?
very simple.
Yes, Adnan.
Yes.
Adnan.
Yes, tell me. First, second, or third class?
First.
E is at the middle. E is at the middle. So it is third class.
Third.
FEEL. Feel.
We are
Mr.
start
It
with
looks
feel.
like a Mr. Can you use
So,
them to
let's-
hold the large stone? You know,
So we will go to the calculating moments. Last time we have discussed this already.
Yes.
Okay, so not only your weight matters, but where are you sitting on the seesaw? That also matters. Like for example, a small baby can balance her mother, but she has to be very far.
Yes.
Why? Why is it possible? Because even though her weight is less, but her distance is more. And if distance is more, the overall momentum, sorry, not momentum,
will be
moment.
more.
Overall
Will be
moment
more.
will be also more. Okay. But in this case, the moment is equal. That's why the seesaw is balanced. That's why it's horizontal. Because 400 multiplied by 1.5 gives 600 Newton meter. This is the moment for this girl. And 600 Newton meter is also the moment for her mother. Okay.
Now, Mister, in the seesaw, where is the effort and where is the load?
The effort is
Effort is on both sides.
And the load?
Wait.
No, see, you
It-
don't call it. You don't call it a lever.
Yes, it's not a lever, but
Lever
there
is like something that you use in your daily life, like machines that help you do your task easier. But this
Yes.
is like a recreational activity.
Yeah.
But when you are lifting a stone or something from a piece of metal, then it acts as a lever. But this one is recreational activity.
But still,
So,
Mister, is the pivot is in
example-
the middle, so it's first.
I'll give you a question now. You have to solve it. And please do not make fulcrum like this. Fulcrum is like
Okay.
this.
Doritos.
Upside down Dorito.
Mister, after I made the fulcrum like this, the gravity has changed forever.
Hmm.
Mister, it's so tiny. The box is so tiny.
It's a chips bag. Chips. Doritos
Oh.
bag. 16 Newton. $250. Maybe.
Okay, you have a seesaw. 15 Newton weight is on one side. Is calculator allowed in your exam
Yes.
in physics?
Yes,
Yeah.
it is
Yes.
Okay, so you can use calculator in this question.
allowed.
Solve this and
I'm
send me.
done.
Mister, I
send it.
can't send
I'm
it.
done.
Okay, no problem. If you can send it, just wait and
Mister,
I'll
I
solve it.
finished.
Okay,
I'm
if
done,
you can
Mr.
send it. Okay.
I can't. Mr. I'm done.
Okay, okay.
Empty. I am not that fast, Mr. I'm not that fast.
I finished, Mister.
The time comparison.
Okay. What are your answers?
For me, it's 0.0853.
No,
No,
I don't
Mr.
think that.
11.71.
11.718.
I
Yes.
don't know. I got like this in the calculator.
A/A.
15 divided to 50.
Let's call this object A. Let's call this object B. Okay. So moment for A will be what? Please write these steps properly. Okay, write like this, like I am
15
writing.
times
Moment for
yes.
A is equal to 15
15
times
times
250.
250.
Yeah.
Or it
Okay.
can be 2.5.
Okay, if you want to keep in meters, but it's not necessary. So you will get 3750.
Yeah.
And what will be the unit of
Centimeter.
No,
Newton per
Newton
centimeter.
meter, Newton meter.
why
Newton.
Oh, Newton centimeter, Newton centimeter.
Okay, so moment
Moment for B equal 320 x.
20x. Okay, for balanced condition,
3750 divided by
Yes.
320 equals X.
I
for
think
balanced condition, what should be the case? The case should be that 320x should be
Over
equal to 3750, or x
divided
is equal to 3750 divided by
over
uh,
320.
Mister, I made the opposite. Instead of dividing 3750 by 320, I divided 320 by 3750.
خلاص. That's game over خلاص.
so the
And
answer
it will
will be
be
11.71875.
718. And
718.
to check whether your answer is correct or not, simply,
I said 718.
for example, your answer is what? 11.7. Now using your calculator, multiply this thing by this thing and check whether the answer is coming same as multiply this by this.
Ah, yes, the same.
This is the same way to measure. Yani if you are getting 0.085, you multiply by 320. What do you get in the calculator? 320
Less
multiplied.
than
3750, the same as the moment A.
No. I am
Oh,
asking
no.
about your answer that you gave
Yes,
me.
yes.
0.085 multiplied by 320 is giving you what?
Something wrong.
Okay, so that's why you can identify
Yes,
that the answer that you found
27
out.
point. Like instead of
27.
yes, 27.
Okay, so the answer is this 11.7.
But
Okay,
Mr.
let's
when I
move on.
multiply but Mr. When I multiplied it by 320, it's
Ah.
at 3749.76. It's not 3750.
Because 11.7 is rounded.
Yes, you have to make it 11.7185.
Yes, so if I take 11.7 multiply by 320, you don't get 3750 exactly. You will get something less than that because we rounded this. Okay.
Okay.
Next chapter. 10, 11, 12. Oh, this one also. Oh, the domino effect. So this one we have seen that center of gravity is important for the stability of the body. If the center of gravity goes higher, it's easier to drop or topple down that object. But if the center of gravity is bottom, the
It will be
object
closer
will
to the
stay
pedal.
stable. Yes, it will stay stable. For example, I explained to you this example last time. When a truck is turning very fast, what will happen? The top, the heavy loaded materials will try to move away from the truck. And what do you see here? This is the center of mass here. This is the center of mass here. In the last case, the center of mass is on one side and the two wheels are on
the pedal,
other side. So
the
what will
other side.
happen? On the bottom
It will fall.
wheel, what will happen? The whole truck will rotate like this and it will fall down on the left side, sideways.
Yes.
Okay.
Mr. This question came in the last test of physics, and like we have to explain the whole thing. I wrote that if the pivot was on the left side of the center of mass, it will be stable. But if it was on in the middle of like at the same level of the center of mass,
Say it again. I wasn't paying attention. Yes.
when the pivot is at the left side of the center of mass, it
Yes.
will like it will be stable. It will go back to the same shape,
Yes.
the original shape. And if it
Yes.
was on the same level of the center of mass, it will like go back to the original shape, but it will be harder. And if it was on the right side of the center of mass, it will topple over.
Yes. So we can say that if even though the truck is turning very fast, but the center of mass does not cross the tire, then it's okay. The truck will come down. After the curved road is over, the truck will come down. But if the speed is a lot, okay, and in a case that the center of gravity passes both of the tires, what will happen? The truck cannot control itself and it will topple down here on this side.
Yeah.
And whoever is standing here, مفروم.
انتقل إلى رحمة
Game
الله
over.
تعالى.
Game over.
Yes. بقى الله. Stability, center of mass. Okay. If the center of mass is higher, the object will be less stable. Yes. Like I told you a toy that day, that there is a toy like this. It has air inside it. Okay. And it is very heavy here. Heavy at the bottom. What happens if you punch it? It will again come back in the standing position. It will not keep on, and it will not keep
Mr.
lying on the ground.
I think, Mr. That's why it's sad.
Because everyone is smashing his face.
At this point, you
So
won't be able to smile or be sad.
now look here. They have given three situations that a guy standing normally is stable. When he bends forward, what he does? When he leans forward, he bends his knees also like this. Okay. So that in order to get this mass little bit on the left side, because this mass is on the right side to keep the balance. But if he does not bring his backside further left, what will happen? This guy cannot go very much down. If he goes a little bit down, he will all the way come down because he will not be able to maintain his center of
You will break
mass.
like Legos. You will
Break like
break like
Legos.
Legos.
So this we have already studied, so that's why I'm not going to it again in a big detail. Now from here we have new lessons: pressure, using pressure, and then pressure in liquids, pressure in gases, not pressure in human beings. Huh? That's not our chapter for today. 6.18 diffusion in liquids. Ooh, yummy, yummy.
شوربة Mr. Mother makes ملوخية, everyone come.
This is pasta, not looks like pasta.
Oh, Hashi Basha. I like Hashi Basha very much. very much.
Like
here-
with the
كنافة مش
camel meat.
كنافة.
No, with the chicken. The chicken meat rice is very tasty there.
Uh,
Even
still
the
cannot
jamal,
do
even the
kunafa?
jamal meat is good, but like I'm not very familiar with that meat. I have eaten it like 2 or 3 times only.
The
But the
man
with,
Never
but
ate
with
it.
the chicken, but with the chicken meat, it's very soft and like very tasty in Hashibasha. You guys
Jamal-
also go to
Jamal-
Hashibasha, or you have any other destination for chicken with rice?
No, there's Mr. Makbous Express. A restaurant called Makbous Express. It's so good.
Makbous.
Yeah, Makbous Express. It's like Kuwaiti with
Hmm.
Saudian, with Emiratian, everything.
Like Arab food mainly.
No,
Not
no,
Indian.
Gulf.
Gulf, Khaliji food.
Yes.
What about Ibrahim? What destination do you suggest if I visit Saudi Arabia for chicken meat with rice?
Mister, I just finished eating and I'm still hungry.
And I'm asking you a food question now. You will be craving for food. Maybe you will order now on Hunger Station. Something.
No, now you'll eat the tablet. Now I will eat the device.
Okay,
Now
pressure.
it's my-
But your voice is like so low. You are very far away from your earphone or something. Or you are
No, I'm
just speaking through your laptop directly without any headphone.
Maybe I am.
Not maybe, that means you are. What maybe? Are you sleeping or what? Now, pressure. Pressure is how much force we apply on
On
a
an area.
particular area. I will give you an example. Okay. For example, you take what? For example, you have something
Maybe
like a bread piece. Not a bread piece. Like something soft.
Yeah, jam on bread.
Halas, ignore. This example is not very good. It's not like suitable. So, like we have studied. What we have studied? We have studied so many things. Okay, pressure, see. Pressure, you have to remember this.
Force over area.
Force over area. Now, what is the unit of force?
Newton.
Newton. What is the unit of area?
Meter square.
So, what is the overall unit of pressure?
Newton meter square.
Newton
Newton
per
per meter square.
centimeter square.
Or
Newton per
Pascal, Mr.
centimeter also. Newton
Okay.
per centimeter also, Mr.
Newton per meter square. Newton per centimeter square also. Wait, I have a call.
And also Pascal.
Yeah,
G.
Pascal.
G.
Hello?
The Mr. have a call.
Oh. Amir. Amir also died.
Okay. So what I was telling that pressure as Newton per meter square also, centimeter per square also you can use if the values are given in
It can be Pascal.
centimeter. But what is Pascal? Pascal means Newton per meter square.
Square.
And in Newton per meter square, 1 Newton per meter square can also be called as 1 Pascal.
A Pascal. So 1 Pascal is 100 Newton centimeter square. Like, can you see that?
If 1 Newton per meter square, okay, which is what? 1 meter square is how many centimeters square? 10,000.
What? Oh
Okay.
yeah.
1 meter square is how
I
much?
forgot.
10,000 centimeters
one-
square, yes.
10,000.
So 1, which is what? Which will be 0.0001 Newton per centimeter square. This is the comparison that you are asking. Okay. So 1 Pascal is equal to.
I mean, that's how to confuse the person reading.
Then why are you asking these things?
To confuse you?
Yeah, maybe. Not to me, to other guys.
Yes.
But what did I write? Newton divided by meter squared, 1 meter square. Yes, so 1 Pascal will be 0.0001 Newton per centimeter square. Oh. Okay, so let's do some questions. Like weight of a footballer is 800 Newton. I will tell you one thing, why the weight is mentioned in Newton, okay? For example, my weight is approximately 70 kg when I check it on the machine, okay? You multiply this by approximately 10 to get the answer in Newton. So my weight in Newton is what? 700. Okay. So Muhammad Amir, what's your weight in Newton?
10,000.
Not yours. I'm asking Muhammad Amir.
sorry. Muhammad Amir or Muhammad Ali? I thought the weight of his stone.
Mister, you are asking me?
Yes.
I was away from the mic. Yes, mister.
I'm asking you, what's your weight in Newton?
I don't know. I only know in the like kilogram.
I already told you the method.
Oh, okay. 620.
620. Okay, Muhammad Amir. Adnan, what's your weight in Newton?
520.
520.
Yes.
Oh. Okay. But in later, like in maybe in this year or next year, you will learn that this is not 10, this is 9.8 something. But to like make it rounded off, we use 10 to make the things easier. Okay. So, but actually it's not 10. Okay. So there is a footballer. His weight is what? Not 800 kg. 800 Newton. Means
Yes.
takriban around 80 kgs.
Yeah.
Okay. And the area of his 2 feet is 200 centimeters square. So what will be the pressure? Force upon area. So it will be 800.
400
by 200.
800 over 200 equal 4 Newton per 4 Newton per meter square.
Is it meter?
No,
Centimeter.
centimeter.
So the answer will be 4 Newton per centimeter square.
Yes. Or Pascal,
400
mister.
meters.
For
The
Pascal.
area of his 2 feet. The area of his 2 feet are 400 meters square. 200
Mister.
meters square.
Mister.
Yes.
It will be 0.0004 Newton per.
No.
Newton per meter square, you mean?
Yeah.
Just keep it aside. Just keep it aside. Yani,
Uh,
it will be like a big thing for you to remember now. So if the question gives you centimeter, just use it that. See, that's why they did not convert it. So just write Newton per centimeter square. It's not mandatory to give your answer in Newton per meter square always. It's not mandatory. Okay, both units are acceptable. Like in the okay, but what is he trying to show us? He's trying to show us that the same boy, same boy, same footballer, 800 Newton, when he uses his feet, the area is this. But when he uses his football shoes, which has very small area, because you are just standing on some points.
yes.
Yes, you are standing on some points literally. So what is the area of those points? It's so less. So when area is less, the overall pressure will be more. Okay.
So, Mr., if the area was more than the force, the pressure will be less, right?
If the area
Is more than the force, the pressure will be less.
the pressure will be less than 1. It will be 0 point something.
Yes, because like 8 divide 200 or something like that.
So what is the result for the same boy when he is like walking barefoot? His area is 200 centimeters square. But when he is walking on his studs, the area is 20. What do you see? Previously, he was generating a pressure of 4 Newton only. But when he wears his football shoes, he generates a pressure of what? 440 Newton per centimeter square. Yani he will have more grip on the ground because the area is less. Okay, his grip, his turning when he wants to take a turn, quick turns, he wants to take a U-turn, it will be very easy for him if he's using his football
Studs.
shoes, but studs. But if he's using his bare foot, he might slip, he might not take so effective turns. Yes, so you
Yes.
guys already play football. You guys can tell me in your real example that when you have played with your barefoot against when you have played with your studs, which one is better in controlling
With
your body?
studs.
With studs, of course, yes.
Yes.
Ahmed Fuad, what's
Mr.
your review on this?
The only
Have
thing I
you
know is that
have you wear a stud and stepped on any human?
stepped on any human, Mister. I've
Yes,
Mahmoud
memes.
accidentally stepped on my foot with studs, and it
Oh,
felt like pain, Mister. It felt like wallah, like pain.
it looked like vaccination, huh?
Yes.
Injection.
It literally felt like injection, Mister. Wallah.
You know,
So
Mr.
yes, Mohammed Amir, you are asking something.
Footballers uses techniques or one technique for pressure to make the pressure less with studs. They like barely let the heels of like their heels touch the ground, so the pressure will be less.
Oh.
Yes, I knew this from Mbappe, Mr.
Now, sometimes, like we studied in friction, that sometimes we want friction, sometimes we want to reduce friction. Yes. Similarly for pressure, sometimes we want to reduce the pressure. How can we reduce the pressure? How can we increase the pressure? By reducing the area. Yani area and pressure are inversely proportional. If you increase area, yani area is more, so pressure will be less. Like if you have more area, pressure will be less. But if you have less area, pressure will be more. But sometimes we want the opposite. Sometimes we want the pressure to be less. In what example? Now look, the weight of earth mover. The earth mover is a machine. Oh, earth mover. I will bring a photo.
Earth mover does not move the earth, mister. That's all I know.
It moves on the earth, yes.
Yes, yes.
Look at this huge. Structure.
Big car
Great.
for big boy.
This. So these are earth movers. Okay. Their weight is what? 1 million Newton. And how many kgs?
Like 100,000 kilograms.
Yeah, 100,000 mister.
Oh,
Divide by 10.
Mass Muallim. Ahmed
10,000.
Fuad. Not 10,000, 100,000.
100.
Because we divide this guy by 10. So cancel 0, cancel 0.
Yes.
What is this? 100,000. 5 zeros.
100,000.
Okay.
Mm.
So
Five.
this equipment is very heavy.
Yes.
Okay. So
So, mister, it's 10 tons. Right? Or 100 tons, right?
ايش هذا الماث يا
Okay.
It's 100 tons يا زلمة.
Yes, yes.
100 ton. Yes, because 100 and then you have 3.
Yeah.
100 ton means 100,000 kg.
ايش هذا الماث يا زلمة.
Okay. So in area, increasing the area reduces the pressure. Now the total area of wait. I think this photo is also not suitable. Earth mover.
Earth mover.
But do you know what is how big is Earth mover? Do you guys know? Or you don't know?
No.
Yeah, I see
I
it
know, I
like,
know, I know.
sometimes in the
Like it's double the
construction
size
area.
of a human, I think.
You will not see this
Double.
easily. Now look at this photo. What do you think? This is Earth
Oh,
mover.
Astaghfirullah. This thing can easily squash me like a fly.
Okay. So area of 4 normal tires is 2 meters square. Okay. Now what happens? But why are they using tracks? Earth mover
But
tracks.
mister, a question. How did they even get in it? That's an important one.
You have ladders,
Yeah, or stairs.
stairs. Yes. Through stairs you go inside.
I feel like mister, in some movies there is big dinosaur destroy city. I feel like this is the thing that will destroy a city.
The modern day dinosaur, huh?
Yes, the modern dinosaur. It will like you stomp on someone, خلاص. You free ticket to heaven. آخر.
Now see, look at this photo. Now I will explain this photo with this example. Now this equipment is very heavy. Okay, but if it was traveling on 4 tires, on each tire there will be a lot of pressure. Why? Because the tire is touching only a small area on the ground. Look, what is the area of normal tire? Approximately only 2 meters square. So for lifting 1 million Newton, if you are using tire, how much pressure is generated? 500,000 pressure is generated, which is a lot, and the tires can burst. They can't bear the load. So instead of tires, what do you see here? You have a chain-like structure, like chains or tracks. Maybe this is known as tracks, but these are chains. So what happens? You have so much area. Look.
Just like the tank.
It's not just on those 2 wheels. No,
Yeah.
the whole
On the
bottom, whole bottom, these chains, they have so much area. Look, this area is so much. Okay, so when you increase the area, what happens to the pressure?
It will be reduces.
It reduces,
the
it
pressure
decreases.
will be reduced.
So now look, the area of track is how much? Too much, 25. So what is the overall pressure on the ground? Yani on the tracks? This 40,000, which is not a lot. The tracks can manage it. Okay, that's where the equipment can move. But if this equipment had tires, the tires would burst because of the pressure. But that doesn't mean that tires are not used for big equipment. I showed you a previous photo. It was so huge, like a building, but still they are using tires. So before constructing these heavy equipments, the engineers do a lot of studies and research that a tire will be suitable, or these chains or tracks will be suitable, or what will be suitable. Okay. I'm not saying that tires cannot be used or it's bad. No, it depends on the situation. Okay. Now using pressure. So you can see that.
There is basal.
Yes, basal, yes.
Basal يكون نظر.
Salata, yes. So for example, if you have a knife that is very sharp, it will be very easy to cut the onions. But if you take a spoon, okay, and you try to cut the onion,
Or,
will it cut?
No, it
No.
will get stomped.
No, it will be
It
crushed.
gets more strong or crushed. Why? Because the area of a knife is very, very less.
Yes.
So the pressure
Yes.
generated is more. But in a spoon, the area is very wide. So the pressure
But
generated is very
Mr.
less.
Sideways, Mr.
Hmm?
But Mr. Sideways it can cut.
You try. Go kitchen and try. Not go home and cry. Go
Also-
kitchen and try.
And we
No,
will try
Mr.
from the onions,
Sideways.
Mr.
Like,
So here we want to increase the pressure. And to increase the pressure, what we do? Take a sharp object. Now, what example is shown here?
Camel feet.
If you want to not get sink in the sand, if you don't want to get, you should have a wide feet. Like a camel has a wide feet. That's why its feet do not sink into what? The sand. But if his legs are like the leg of a goat, very thin, what will happen? The goat will not be able to grip properly in the sand. The legs will keep going in.
and you
You know the
will
legs of the goat? They are so
Yes.
thin, not very
Christian,
wide.
Mr.
And-
You mean Cristiano, Mr.?
Uh,
We said
Ooh,
the
you have also started. Oh, English teacher.
Mr. It's the meme. You remember the meme in 2021? Saparai Delta Show?
What?
There was a meme for an Asian person that he sings. He looked like that person.
maybe he is him.
No.
Maybe you are talking about Stephen He.
Yes, he looks like him a little bit. Just make that hair go a little down.
Stephen He. This one.
Stephen She.
Ha.
Uh-huh.
So weight of the camel is 5,000 and weight of the horse is 4,000. But look, even though the camel is so heavy, okay, what is the pressure generated on its feet? The pressure generated on its feet is only 2.5 Newton per centimeter square. But look at the pressure on a horse, 10. Yani even
Yeah.
though the camel is so heavy, but still the
But Mr.
pressure
also,
on his feet is less than the pressure on horse. Why? Because the horse feet are not very wide, but the feet of the camel is very
Camel are
wide. That's
very
why
wide.
one of the reason is that's why ship is known, camel is known as what? Ship of the,
Sahara.
yes, ship of the desert, yes.
But also Mr.
Safinatu Sahara maybe. Yes?
Yes, Safin's Sahara.
Yes.
But also Mr. The horse's legs, the horse has more pressure so it can control itself, right?
No, I mean,
No, like has more pressure because it lives in an environment with the soil, dirt, Mr. It wants more pressure to hold into the ground and control more, Mr. Like football.
because horse
Studs.
specializes, yes, horse specializes on running and turning.
Yes.
So it's his specialty. But camel is not like famous for running. Yani when you imagine in your head which animal is famous for running, you will think about horse or cheetah, something like that. You will not think
Cheetah.
camel. But when you are thinking about traveling in the desert for so long, which animal can
Camel.
stay thirsty
Camel.
without food and can walk for hours and hours? Camel. You will not think horse at that time. So this animal has a speciality in itself. Horse has a speciality in itself. Okay. In what? In Surah Ghashiyah, you have that. أَفَلَا يَنْظُرُونَ إِلَى الْإِبِلِ كَيْفَ خُلِقَتْ. Yani, don't you see
Yes.
that how we built the camel? How amazing his structure is?
Very amazing.
Okay. So handles and straps. I should hide his face. I see his face, I'm laughing.
Mr. Smiling is an infection, Mr. And it's a good infection.
Yes, now he's wearing a helmet, a corona helmet that I was wearing
No, he's
when I was
bleeding, Mr.
teaching.
He's bleeding. He's a bat. He's bat, Mr. Can see.
He's bad, he's upside down. So handles and straps. Wide handles are more comfortable to carry than narrow ones. Yes, because if you have a very heavy suitcase and the handles are very thin, what will happen? Your hand will get pained. Yani it will be
Very, very.
uncomfortable to hold it for very long distances. But when you have a wide handle or strap, it's comfortable, yani, because your hand does not get a lot of strain or pressure.
Perfect.
Okay. And bike tires, like if you have a very thick tire, it will be difficult to ride on the road and you will apply a lot of pressure. But if your cycle tires have very thin tires, it will be very easy to ride the cycle. But the wide tires, where are they useful? In uneven areas, uneven roads, to get more grip. Because if you have a thin tire here, it might not be like gripping a lot. Okay, so look, the tires on road bike are much narrow than those on off-road bike. So here on the road, you have very narrow tires, but on the mountain bikes, you have wide tires.
We have
What is this guy doing?
he's ينفخ بالونة for حفلة.
A balloon burst. And this photo is taken from a very high-speed camera. And as soon as the balloon is bursting, the photo is taken.
No, before it even burst, he recorded also the air particles.
Yes, very, very amazing photo this is. Okay, pressure in liquids. So these are the three different structures of matter. And you see the molecule movement here, the arrangement. The solid, the molecules are tightly packed. In liquid, they can move little bit. Here, like in liquid, they can vibrate here and there, or even move. But in gas, the particles are so far away from each other. Okay, so liquid can be compressed slightly. But they are telling liquids cannot be compressed. The particle in a liquid are very close together, so liquids cannot be compressed. Liquid can be compressed, but very slightly. Okay, but if they are telling you that they cannot be compressed, okay. But in our school, we studied what? The solids cannot be compressed. The liquids can be compressed, but very slightly. And the gases can be compressed easily. Okay, like for example, in this syringe, in this injection, you fill powder and then you try to press it down. Will it move? No, it will not move. But if this whole syringe is empty, only air, what will happen? You can push it downwards, even though it will come out outside because of pressure. It
also,
will come
Mr.
outside.
But also, Mr. In the liquid, sometimes if it's sealed, like the ceiling will just برا.
Ceiling is what are you explaining with sounds, with Arabic, with English?
3 languages at once.
Imagine you are on the graduation party, you are on the stage and you have to give some speech and you start speaking like this. Baden moya, barra baden, inside water, and the whole hujum will start laughing.
هذا أنتم.
Khalas, now relax. Now relax. So we see that now we are going to study about what? About liquid. So we are not going to study about solid pressure. Okay. Here we are going to study about liquid. Here we are going to study about gas. And the last one, diffusion in liquid and gas.
I think we took that also in biology.
Yes. So here, up first, I taught you yesterday that the water pushes you upwards. That force is known as up thrust.
Yes.
Okay. And when you fill up a polythene or a plastic bag with water and you puncture it, you make some holes, what will happen? The water will start coming out from all the holes because water has pressure.
But Mr. Why when you stab a pencil through it and keep it there, it doesn't remove water?
Where?
Like sometimes, Mr. They do tricks where they punch a pencil through the thing and it doesn't bring water out. Like the pencil is still in there, it's stuck.
In the magic tricks?
Yes, Mr. They stab a pencil inside it and then خلاص ما في موية برا.
You have some translation issue or what? Why not speaking in English continuously?
Can you please at
Okay.
least answer the question, Mr.?
See, the tricks mostly they are using, they have some special devices for every trick. Yani if you see the trick revealing videos, you will see from the perspective of you, it looks like a normal card or normal balloon or normal pen. But if you see the other parts or the inside, those materials are made slightly like they can do multi-purpose things.
Okay.
I'm talking not about this trick particularly, I'm talking about general. That if you type that how this trick is done in front of people, you will find the pencils they are using, the card they are using, the currency notes they are using. All of them are not normal. Either they are two stuck together, or either it is one inside it, or either you have a plastic sheet within them. There is something hidden there. Some trick is there. That's why it's not your daily behavior of the material. That's why you get tricked. Oh, how did this happen? So I cannot answer the thing that you are asking now because I don't know what kind of material they are using and what trick they are hiding behind it. Okay. So for example, you might have seen a dam on internet. Have you seen? I'll show you.
Yes, dams are very big, very, very big.
Like this. There is a river.
Yes.
And they stop the river water by a big concrete structure to stop the water. And then they use this water according to their will. And if they want to release the water, the releasing gates are here.
Where does it go, Mister?
No, it's filled with water. When
Like
they
Mr.
want
the
to,
Nile River.
when they want to release the water as per their requirement, or they have some demand, they open the gates here and then the water moves. So what are we going to understand here? That on the top surface of water, the pressure is not a lot. That's why the thickness of the dam on top, and this is the front view. Yes, this is the front view, but this is what? The side view.
The back.
Not the back view, the side view.
Mhm.
If you look it from side. Okay, so on the top, see the thickness of the concrete of the wall, it's so thin. Why? Because here the water does not have that much pressure. Then why should I construct building like this? Okay, and this extra cement is waste for me, extra concrete. But as you keep on going down, the pressure increases and increases and increases. Look at this deep, it is so high pressure. That's why you need thick.
Like if it was a
wall.
thin wall, the pressure of the water will break the dam, right?
Yes, yes. The pressure will break. If you built a dam like this, with this
It will be
thickness,
broken.
it
will be
will
broken
break it,
instantly.
or it will topple it. And this
Yes.
wall will come down.
Yeah.
And the water will push it down. So it cannot hold. That's why at the bottom of the dam, the thickness of wall is more. But at the top, the thickness is less. And here, measuring pressure, you have a pressure gauge. This device is used. Like, for example, this meter, you see it on the fire extinguisher in the school. But this is not this big. Yani, these are like pressure meter. You have this pressure meter, you have the needle, and you have some readings.
Mhm.
Yes? On the
Mhm.
fire extinguisher. So,
Mhm. Mhm. Mhm.
yes. Did you take your
And
medication today?
mhm. Mhm.
A diving vessel protects diver against the pressure in deep water, like submarines also. Submarines go to a very deep level in the ocean. At that level, a normal human being might not survive because the water pressure is so high. His blood veins might burst. But inside the submarine, they create pressure like that so that a human being does not get crushed, or his blood veins do not get bursted. Okay, inside these vessels, like in aeroplane. In aeroplane, why it is advised to keep the windows closed? Like in the, I mean, the
Because
windows
of
are already
the pressure.
closed, but I'm talking about the, for example, the private plane or the small planes. They have the windows that can be opened. But you might have seen videos on YouTube that if they open it by mistake, it's so huge pressure that even it tries to pull you outside. Or it's so difficult to close the window. Have you seen some videos that by
Yes.
mistake some passenger or some like opens the window and everything starts going outside?
No, wait, yeah, because of the pressure inside, like I think it decreases by a lot. So the pressure outside is wait, I think I did mistake, right?
I'll show you some funny thing now. This guy,
I don't see
no, it's
anything.
coming, it's coming. Anakari, it's coming. This guy thinks
And
that he will take the mobile out and he will take photo. But as soon as he opens the window, look, the mobile goes away
The phone
because
will
of
fall.
the pressure. Not only fall, it sucks away and the mobile is gone from his hands in a second. Look this poor guy. The bad guy is is encouraging him, mashallah. A good job.
No, but Mr.
He's patting him.
لا تقلق يا حبيبي لا تقلق يا حبيبي.
So that's why it
أنا
is
آسف يا
advised.
حبيبي.
That's why it is advised not to open the windows in planes.
لا تقلق يا حبيبي.
Okay, so this contains a tube that is curled up. The tube straightens out as the pressure inside the tube increases. This moves a needle to show a reading on the scale. Now here you have coils. So when a strong pressure is generated in the coils will try to become straight. And if, for example, if you have a pipe, you know what is pipe? Hose. You have a pipe, water pipe, in which you use to water your plants, to water your garden. Yes. So,
Yes.
for example, this hose is lying like this, but when you put a very heavy pressure, what will happen? The pipe, the hose will try to become like straight. Similarly, in this coil, what happens? This coil is twisted like this. But when a heavy pressure goes through it, what happens? It tries to become something straight. In this way, the needle moves. So you can judge, okay, what is the pressure inside? It is high pressure or low pressure. Okay.
Okay.
Mr. I think we like see this pressure meter in the when we want to make balloons, right? In the helium can.
I think yes. And also when you go to the petrol pump,
Yes.
and when that guy is filling the air in your tires.
Yeah.
Yes, there you see.
And then the tires pop.
So now pressure in gases. Okay, gases can be compressed. And what affects gas pressure? Now you have to remember what? Adding more gas, changing the volume or temperature. Yes. For example, if you heat the gas, its area will increase. I mean, its volume will increase. So I will tell you the summary here. When the pressure is higher, so when the volume is smaller, when temperature is low, pressure is high. Okay, high pressure. But when you have high temperature, heat area, what will happen? Low pressure.
Mr. There is a mistake. Low pressure, which means low temperature. High temperature, which is high pressure.
High temperature is high pressure.
Yeah, I think you wrote at high temperature, low pressure.
High temperature is low pressure.
Yes.
Look here.
Wait, what?
That's what I'm writing.
But Mr. It says when the temperature is higher, particles move faster and there are more collisions and the pressure is higher. It says, Mr. beside the decrease of volume.
Look,
Mr. It says here, Mr. Above
look
higher
here.
temperature.
Warm air is lighter, yes, than cold air, and consequently exert less pressure. Yani warm air is less pressure. That's what I tell
But
you.
Mr.
Warm
It says here,
temperature is less pressure. What's the issue?
but Mr. It says here above, when the temperature is higher, particles move faster and there are more collisions and the
Huh?
pressure is higher.
When the temperature is higher, when the pressure is
It
higher.
says here, Mr. Like above, Mr. in the book, above
In the
the higher temperature.
Okay,
Yes, here
let me
above.
okay. Let me see what's written in the next page. No, here only.
No, on this page,
Yes. Gas pressure changes when the number of collisions between gas particle and the container was changed. There will be more collisions if the particles are moving faster. The particles are in a smaller volume.
And increasing temperature here.
Particle in a cold gas, particles in a hot gas.
And under it says when the temperature is higher, particles move faster and there are more collisions and the pressure is higher.
The temperature is higher. Okay, the particles move faster. Wait, I need to check it because this screenshot that I brought here says otherwise. Let me check something else.
Okay.
The pressure if ever the temperature decreases. Now other website is also saying the same thing that I said. Look.
But Mr. also, like if we do not.
Mr. It will like the
So
pressure
that
Look
is
here,
answer,
look here, cold air,
they will
cold
put it
air
wrong in the
has
test.
cold air has high pressure.
Like Mr. Like also Mr. If, like most of the times at the exam, if you write different from the book, they will minus you from your marks. So I think like we
Ask, okay, what I will suggest
So I
you,
think like
ask your teacher this question. That what is the relation between temperature and pressure? Khalas, ask him this question on WhatsApp or wherever you want.
But Mr.
Okay.
He said
What?
one time in class. He said one time in class like whenever the temperature is higher, the particles will move faster, but the pressure will be less, like less pressure, more temperature, and more faster movement of particles. I remember he said that.
Ask him this question. Okay, I am making it bigger in size. If you remember, ask him this question. What is the relation between temperature and pressure? Okay,
Ask him
so
tomorrow.
So then tell me what did he say? Okay, so until that time, we are going to the next topic now, atmospheric pressure.
Marshmallow.
So atmospheric pressure, yani the atmosphere around us also exerts a pressure on us.
Yes.
Like you have molecules above your head and above your head, 10 meters above your head, 20 meters above your head, until all the way until the layers. Yani there is a lot of pressure on everyone. Okay. One example they have given, this experiment can be found on YouTube also, I think. I have seen something like this, that the marshmallows contain a lot of air pockets inside them. Okay. So the atmospheric marshmallows contain pocket of air that expand when you pump out the air around them. So in this case, they remove the air of the container.
Marshmallow.
So what happened? No, not the marshmallow.
Oh,
They
yeah,
remove them.
like
So
the
what will
cup.
happen when the air is leaving outside? The marshmallow will become big in size. Why?
Yes.
Because it is like sponge. it has a lot of air spaces inside it. So when you pump out the air, the marshmallow will become big. But when you
Like the inside,
open the
inside
lid,
air,
when you open the lid of the container, when it comes to the normal room temperature, it will again become like its normal size. What are you saying?
because Mr. Can I explain?
Yeah.
Because Mr. The air inside it pushes outwards and the air outside pushes inwards. So it's not getting bigger or smaller, but because there is less
Yes,
air,
it's balanced.
it pushes out more. It's not balanced when there is less air inside, but when
No,
there
in the
is more
first
air
scenario, it's
outside, it's
balanced.
balanced.
When the container is
Yes.
open, it's balanced state. But the second guess you are telling,
Yes.
that is the unbalanced state. Yani
Unbalanced.
the air wants to move out. When the air is already moved
Also,
out, then
that's
what is remaining? The marshmallow will start gaining its size.
so, Mr.
Okay.
Will the marshmallows get bigger? So is this like infinite marshmallow hack?
No, it will be. It will get smaller when the air like gets back to it.
Yeah, so if I trap myself in an oxygen-less room, I will get infinite marshmallow.
And how will you live without oxygen?
I have an oxygen tank.
Yes.
Oh, so you love marshmallows a
And
lot to the extent that you are ready to
Okay.
die for the marshmallows. Okay.
Mister, can you explain the cylinder thing? Or the oxygen tanks?
Okay. Adnan, Badr, and Ibrahim, are you guys there?
Yes, Mister. Yes, Mister.
Okay. Ibrahim is there.
Yeah, but I'm far away from my mic.
But are you with us or somewhere busy just showing us online? Okay, Ibrahim with us, but not actually online with us.
No, I am with you.
How are you talking when
What were
muted?
you asking, Muhammad Amir?
No, I'm not asking. Oh, yeah. Before, like explain the oxygen tank thing for 3 things the gas has to be compressed because of them. The part of the firefighters. Say some firefighters use oxygen tanks. Can you explain that?
Okay. Oxygen compressed into tanks help the firefighter to breathe. Really, since when the fire is there, fire takes up a lot of oxygen because oxygen helps in burning.
Yes.
So when there is a lot of fire, what will happen? There will be a scarcity of oxygen. Oxygen
Yes.
will be very less. So how will you compensate? How will you breathe properly if you are a firefighter? So for your safety, you carry oxygen tanks also. So if in case you feel short of oxygen, you use your oxygen tank. Okay. And why it is compressed? So that you can fill in a lot of oxygen. That's why it is compressed.
Okay.
Because if you don't compress it, the quantity that you will take is very less. That's why. Okay.
Now the last chapter. Final
Last chapter. Yes. I think I will not take a break because if I take a break, then I have many classes today. Zahma, Marra, Zahma.
Yeah,
So
final.
that's the last thing. Then I think for worksheet, we need to take one another class.
Yes, we can take it on Wednesday if you
Wait, I
you
have a
want.
phone call again. Sorry.
Okay.
From my family.
No problem.
Okay. Amir. 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 Oh,
Okay. So let's try to finish this one, the last one, and then as soon as we finish it, we will end the class. So
no,
because
Mr. But Mr.
we cannot
Can I ask
do
a
the
question
worksheet
on the
today.
worksheet?
Good.
Can I ask a question on the worksheet?
We can keep the worksheet for the next term. I have the still
What next term? Next term, Mister?
not term. I'm saying turn. TURN. Next turn. Yani marra illi
Not
jai. Not term illi jai. Clean your ears. I'm saying the next turn. Okay.
It
Your
sounds really
exam
similar.
of physics is on 8th of June. 8th of June.
Thursday, Mr.
Thursday. Yes, Thursday.
Yes.
So what I recommend, have your teacher started solving the worksheet with you?
No, tomorrow and
No.
after tomorrow. He said tomorrow and after tomorrow.
So what I will suggest, you guys try worksheet for yourself, and if you feel the need for another extra class for physics revision of worksheet, then I will make a class. But if you guys can solve, because I have explained each and every lesson, if you guys can solve, good. No need for another session for physics. Okay. So I will let you guys solve some things first instead of me explaining everything and then solving. No, you guys have to make effort. Okay. Not load and not fulcrum. You have to make effort. Okay. Diffusion in liquids and gases.
But
So,
what is this, Mr. Food? What
no, this
type of
is
food?
an example that when your food is being cooked
Yeah, we took it also in biology.
in the kitchen. Yes, we took in biology and respiration that when someone is cooking food, then that whole nearby area, you can smell the good fragrance of the food. That's what we are studying here, diffusion. Any food particles diffuse into the air. They get mixed, they get spread a lot, spread in all the directions. Okay, that's what diffusion. Look, the random movement and mixing of particles is called diffusion.
Yeah.
So particle in gases and liquid are moving. You do not need to move or stir a substance to make diffusion happen. Yes, for example, in a kitchen, when your mom is making something delicious, is she opening the fan so that the smell goes to the whole house? No, even though she is not using any fan, but still the good fragrance of the food reaches to the farthest of the room.
Yeah,
Okay.
it goes from high concentration area to a lower concentration
area. Yes,
yeah.
We studied that in biology.
Yes.
The diffusion. Okay, so diffusion in gases. Now one example is given that there is air, and there are two containers separated by what? A wooden lid or a plastic lid. Okay, on top you have normal air and bottom you have bromine vapor. But when you remove the lid, what happens?
It will be a mixture.
The whole mixture is there of bromine and air particle. They will get mixed. Are you using a spoon inside to stir it? No, they will diffuse it automatically.
Yeah.
Okay,
Like
this was diffusion in gases. What about diffusion in liquids? Sometimes you don't need to mix some things.
Yes.
Like you don't need to stir it. You don't need to mix it. Well, it will automatically, like they have given an example. You have water and then you put something inside, and then after some time the whole water becomes pink.
They mentioned
and what
crystal,
is
Mister.
Huh?
Crystal diffuse into the water.
Crystal. Okay, the purple crystal. I think it's potassium permanganate, maybe. Is the name given? Potassium manganate.
Yeah, potassium.
Not permanganate.
But Mr. Like when we pour oil with water, they will not mix together.
They will
Like,
not mix. No, no,
yes.
not everything. Not everything mixes.
Yes.
Oil and water will stay separated, stay away.
Yes.
Okay, now diffusion and temperature. Now again, there is a relation between diffusion and temperature. Particles from warm food diffuse more quickly. Yani when temperature is high, diffusion is high. Okay. But when temperature is low, diffusion is also
low.
So these type of questions can come in fill in the blanks, that when the temperature is low, the diffusion is also what? Low or high? You have to say low. Okay, but in liquid and gases, in which medium diffusion is faster? In liquid or in gas?
No, gas.
In gas, it is faster. In
Yes.
liquids, it's not very fast. Why?
Because in gas,
Because the gases
move
particles
fast.
are so away
Yeah.
from each other. Okay.
Yeah. But
That's
also,
the
Mr. The liquid particles move over each other, so they like also they stir together or mix together.
Yes, they have crowded. Yani they have more crowd.
Yeah.
Then. So I think we will end the class because I have some tasks also now. So Alhamdulillah, we have completed in 2 days 18 lessons, like we have already taken already before, but it was a good session.
Yes.
Okay, so now I think it's the end. And what is my recommendation for you? Open the worksheet yourself and try to answer the questions. If you have any difficulty, you can ask me. Because
Okay.
now I don't think so. Like we can go through worksheet now in this session. The time is almost done.
Yeah.
So we will
almost.
decide later, inshallah. Okay, we will decide later. If a lot of students have too much difficulty in worksheet, we will make class. But if the teacher, your physics teacher, is solving everything in the class and you guys are understanding, then no need for separate class of worksheet. If you have problem in one question or two question here and there, post in the group. When I have free time, I will share my answers.
Okay.
Okay. Assalamu alaikum warahmatullahi wabarakatuh.
Assalam.
Bye.
Bye bye.